So, hi everybody and welcome back. This is a C++ tutorial series for absolute beginners. This is video 65, and in this video we are learning a new keyword. Actually, we are learning 3 new keywords, but they belong all together. And these keywords are try, catch, and throw. And because they belong together, they call them also try, catch block. And let me make here an example. Try is the first keyword. Then we open up the curly brackets. This is again our body where we write the code, and this is the code which we want to try and test. And if the code has any errors here, we can throw an arrow and catch it with the next word, which is the next keyword, which is catch. And here we will in this round brackets we will write later an exception handler, or exception handler means here an error handler, because the try block said I found an error, and the catch block says okay, I will handle it for you. And how he won't handle that we can define here in this one, but there are 2 ways actually, and I start in this video with the let's say with the easier way, and in the next video we will use the normal way, which is the standard exception, which we should use all the time. But this way is more custom. So let's continue. And how I'm going to use this custom way, I write here a number, and I initialize or declare here just a number. I call it in my case int error code, because this throw will be something like an information about an error, and that's why I call it error code. And then I have here again this curly brackets for the code. Also here I write how I want handle this error which occurred here on top, and I have to use the one error code also, which is throw, and this throw I write here in the try block. And in this case I write just a number, let's say number 1, and of course this number has a meaning, and this number which you see here, throw 1, will be used here. Right, this is this kind of use we never learned so far, but in this case it's a special case. It's a try catch block. The throw is connected here with this one, which means any number will be included in here, and then we can use this number to specify or to get information or to take actions to handle this error on top. So this is the general system how it works. But actually what is very important here to note, a try catch block, when you, let's say you want to write a try catch block, normally you don't start with a try catch block. What I mean with that, the try catch block is a check system for an existing code. So normally what you have is you have here an existing code, and then you add this try catch block around this existing code, because you want to test your code or try to catch errors or something like that. That's the reason why you normally not start with a try catch block, only for exercises when you learn it on so. But in real programming you don't start with a try catch block, or you would know it that you want check something, of course, then you start also with a try catch block. But in general, let's say we don't start with a try catch block, and for this reason I prepared here a little bit random code which we can learn how to use this try catch block and how this all works, and then we see it. So here on the bottom I prepared something. Let's me copy it. What I need here, actually I need here this part till this one too, yes, I think till here, till this catch part. Okay, let's copy this one, let's put it here on top, paste it and uncomment this all, and format all. Control KF for formatting, holding the control. So, and now you see I have here and code, and this is my starting code. This has nothing to do with try catch. This is just a code I generated. And let's repeat here also a little bit what we learned so far. This is also a good thing to repeat something. And here, what I have here, let's check this out. First of all, I have here on top enum class, and we know enum we can make in 2 ways, actually 3 ways. We can use even a struct, but we have not discussed struct. And then I have this enum class. I have here main menu, option menu, character menu, and this one I made just intentionally. I made an error here menu, something like that. And then I created a menu from this enumerator. This is a type. I created now a variable, and then I created here this game menu selected menu, and I assigned it a default value. And in this case, I want check the error. That's why I write here I made an error. And the error is I have only 3 cases in my switch statement. So the error was here, I created here a switch statement. The switch statement can select values from this enum class. We learned this is just a type, and I can select only what it's in here. I have here 4, but the problem is I made here a big error, and the error is I have only 3 cases. 1 case for the game menu, main menu, then I have a case for the option menu, and I have a case for the character menu. But I have no case for I made an error. But instead I have here something like a default, and we learned all this also switch as this cases. Then we have this curly brackets. Careful, sometimes they don't use these curly brackets, but we use it to specify it a little bit more. And we see the scope. We learned also a little bit about scope in the last video, and we learned also that this variables which I created here, this one, and or this is not a variable, this is just a enumeration type. But this variable is now local, and we have to ask local to what. All time check this curly brackets. For example, this variable is local now to this int main brackets. And if I want to make this global, what we do there, we have to bit it out. We can make it global, which means I push it there on top. But you see, I have now here a problem. And what is the problem here? I have here the game menu, which is this type, but the problem is it is created later and it is in local. So when I make something like that, I have to be careful that I make this also global. So now it is created first, and after that I created my variable. So when I click this one, you see it connects automatically. This this box here indicates yes, it's connected to this one, and it's connected also to this one, to this one, and to this one. And that's also a very nice thing. So we can select here global or local. Most time local is better, but in our case we can say I throw all thing on top at start. We have only here one CPP file right now that can work, but can also cause problems later, and how this can cause problems we will learn later. So this was my starting code, right? And this is the thing what I want to test. I have here just a switch, and I can select, and I have not covered this case here that this selected menu, this variable, can have more values available. I just created, let's say, randomly fast without thinking only these 3 cases, but I was at least so smart enough to create a default value, and default means for all cases which you have not covered, use this one. And here I said std cout unexpected value, which means while I created this code with the switch, I thought I will only need these 3 values, but yeah, the code was changed anyhow, and they had even more values now. Anyone created here some more or added here some more values to this game menu type, and then it happens that this default is activated and it says unexpected value, error code generated, and then I say throw 2, and this 2 means then unexpected value in this case, for example, right? And then now we come to this. Oh, this was actually one step ahead, because I forget that we have to check this code, right? Because right now I have no check, and now this try catch block comes in account. First I have my code which I want to check, and then I said I'm not sure if I can this can change in the future or so. So then I write, okay, let's check this code, try, and then you open up this curly braces, and what you do here is you open up 1 and put this one around the code which you want check, in my case around the whole thing what I generated here, and you see it's automatically formatted in my case. That's nice. This code will be checked, and this throw, yes, this was already there. Normally you write this throw also later after you generated this throw 2, and now of course you have the try block. This will be checked, and now you need also the catch block, and then we write here catch, and here again int error code. This is the same because this is just a declaration of a variable. Important is here this int error code is connected to this throw. So for example, if you throw here number, this int error code will take this number, and you have to interpret this number. In this case, for example, this one is unexpected value, and throw 2 is perhaps a very danger, let's say, not a danger. You have to check if this can cause a very bad behavior of your program. If this is happen, then you say I need error code which stops the program. Or it can happen that the customer crashes PC, or your PC is crashing when you go on, because this value was very important. And so you have to interpret this value. In my case, I say I want stop this code here if there is an unexpected value, because it can cause perhaps crashes, and I don't want that the customer or my PC is crashes only because anyone extended this type here, and the switch status could not find here anything. Of course you can handle this here another way too, but this is just an example. And then I say I want stop it, I can't handle it, I don't know why this type has more values than this 3 which I generated. I expected only this 3, now it has 4, I don't know why. And because I don't know why, I don't know what happens next in my program, so I want stop all. So, and what I do to do this, because right now I only explained what I want to do, but how I'm doing this, and actually there is also a very easy way. And what I did here is we make just this if checks, and then we define it. Let's do this here too. So I say I take this int error code, and then I say, let me uncomment this one fast, uncomment and KF for format, so that we can see it a little bit more stylish. And then I said, okay, I take this error code, this throw will be here, and if it's, let's say, if it's 1, I know this is not a bad, anything bad will happen, right? Here I said if error code is 1, and then I wrote just an output, error code 1 occurred, can be ignored, it's not harming the program. In this case I said anyhow this error code throw out at 1, that means that was something that will not harm my program, or it will not cause a crash, or all things can go on. So error code means here no problem. But here I said in my example program here on top, I said, wait. Here I don't know what can happen. I expected only really these 3 things. Anyhow, it comes here to 4 things, which means the default is activated. And because I have no clue, I say I want to stop the program. And that's why I throw here the number 2. And as I said, then I just created a second if statement. And then I said error code equal to. Then I said here std out error code 2 occurred, cannot be ignored, program terminates. And here I said something which we have not talked about and we'll talk in later states when we go for logging. And will be logged. Will be logged means this error will be generated behind the scene a text file for the programmer, which he can check where the error occurred, when the error occurred, and so on. There are many things which can be which will be written for the programmer so he can check it. Because the problem is here, this line which you see here, it can happen that you even don't see this line here because an error was occurred and the error was really bad and you want to terminate fast. And here's something new what we not learned, and this is only to close the program. For example, I used here again a function we will learn. We have not discussed what functions are, but in this case, this is a function which says I will terminate this, I will close this program. So it goes not on at this point, and all what you made here so far, I will shut them down. And yes, let me demonstrate you this one, how this looks like. So when I start here the program, you see what happens is it says here unexpected value that was here on top. Error code generated, that is, this is actually you could here also generate an error code with int error code and then write this error code special and use this as another asset also to help you to get an understanding what this code is, and then print out this in this log file later, something like that. But I generated it not really, I just throw this throw 2 is like an error code. So this 2 in my case is the error code. And then I said throw 2, then it goes down here to this catch block. This 2 is used here in this int, and then we see error code 2 occurred because it checks which error code. We have 1 is no problem, you could go on, but error code 2 cannot be ignored, program terminates and will be logged. And you see the program here is stopped. I can't go on here. And that's very important also to know that there are error codes which say you can go on, but there are error codes where you want not go on. Right, let me show you this one here. And to demonstrate this a little bit better, let's see, what is this? What is that? Throw 1, here's nothing. That was our just start point. And here we make here std. This is just a random code here again, just to demonstrate that the program can go on or not go on. The code continued here. Just as a reminder, let's test here this 1. And 1 means error code 1 occurred, can be ignored, it's not harming the program. Let's say anything happened here again, but this time I know it was, let's say, just an unaccepted value. For example, instead 1, it occurred 2, and it says here unacceptable value, error code generated. Error code 1 occurred, can be ignored, it's not harming, will be logged, the code continued here. And you can see what I mean here. After this one, it has just continued your program because this error code was not a really danger one. It will not cause a crash, but it is still an error, right? So, or let's say a warning or something like that. That's why will be still logged, but your code, what you have here, is running on. And let me show you this one fast again. With Q, this code here will not be continued because you after that it can crash and you want definitely stop it. So at run again, and you see this time after this one, you don't see this line of code anymore because it's exactly stopped here with this SDA exit. Stop here, definitely. So that was actually the first part. And in the next part, we change only this section here. And we will use a standard exception, what the C++ is using. So see you in the next video. And if you have any questions, like all time, write it in the comments. I try to answer them. And good luck.